Question 18 on the 4-6 test and question 9 on the 5-7 test. Match each instruction on the left with an instruction on the right that has the same effect. The first one is done for you. So they've matched up add 0 and subtract 0, the same thing. So we've got add 2. And on here we've got to choose from add a half, subtract a half, add -2, subtract -2. Well, we should be able to rule out add a half and subtract a half. They're clearly not going to be the same thing. So we've got add -2 and subtract -2. Well, there's no way that adding 2 could be the same as adding -2. So that only leaves adding 2 being the same as subtracting -2, because taking away a negative number is the same as adding that number. So add 2 matches up with subtract -2. Subtract -2 in the same way it can't match up with these two because they're a half, so subtract 2 matches up with add -2. Question 19 on the 4-6 test, question 10 on the 5-7 test. Pupils are investigating oak leaves. They want to collect a sample of oak leaves. Here is their plan for how to collect the sample. Choose one oak tree. Take 10 leaves from the lowest branch of the tree. Give 2 reasons why this sample of leaves may not be representative of all oak leaves. So there are lots and lots of reasons that you could pick for this. I'll give some examples. You could say the sample is too small and they should pick more than 10. You might say that they should choose more than one tree because some of the other ones might be different. You might want to say that they should choose trees in different areas. You might want to say that they should pick some leaves from higher up. So there are lots of reasons. So the 2 I'm going to give are they should pick more than 10 and that they should use more than one tree. Question 20 on the 4-6 test, question 11 on the 5-7 test. Look at the rectangle. The total area of the rectangle is 40 centimeters squared. Work out the lengths of x and y. Well, to work out the area of a rectangle, we do length times width. Let's start by thinking about the big rectangle, the whole thing here. To find the area of this rectangle, we would do 4 multiplied by x, and I'll write that as 4x. And the area of the big rectangle is 40, so I can say that 4 lots of x is 40. So I've got an equation here, and if I divide both sides by 4, I get x equals 40 divided by 4, which is 10. So I'll write that down here. I'm going to write this 10 up here now because I know that that length is 10. If I know the whole length of this rectangle is 10, and the length of this part here is 6.1, the rest of this that's added to the 6.1 must make it up to 10. So to find y, I need to do 10 take away 6.1. You can do that in a column sum if you need to, you might not. It's 3.9. Question 21 on the 4-6 test, question 12 on the 5-7 test. Part A says bags A and B contain some counters. So in this one we've got 6y plus 1 counters, and in this one we've got 4y plus 7 counters. The number of counters in each bag is the same. Work out the value of y. Well, if this is the amount of counters in this bag and this is the amount in this bag, then these two expressions here must be equal because there's the same number in each bag. So that allows us to form an equation that says 6y plus 1 equals 4y plus 7. To simplify this equation, I'm going to subtract the smallest number of y from both sides, which is 4y. So take 4y from both sides. 6y take 4y leaves me with 2y. I've still got the plus 1. Taking away 4y from this side would make that disappear, and I'm left with positive 7. Next, I'm going to subtract 1 from both sides. That's going to get rid of this term here. So on this side, I'm left with 2y. On the other side, I'm left with 6. And then finally, I'm going to divide through by 2 and get y equals 3. So my final answer for work out the value of y is 3. In part B, it says bag C contains more counters than bag D. What is the smallest possible value of k? So that's saying that there are more in this bag than there are in this bag. To find the smallest value of k, let's pretend that they've got the same in each one, and that would mean that 4k is equal to k plus 12, much like we did in the problem above. If I take away k from both sides, that's going to get rid of k here. All I'm left with is a 12 on that side. Taking k from this side leaves me with 3k. And then dividing through by 3 is going to give me k equals 4. But remember, there are more counters in this one, so the value of k can't be 4 because that would give us the same. So the value of k has to be one bigger, which is 5. Question 22 on the 4-6 test and question 13 on the 5-7 test. Gary took part in a quiz show and won £1 million. He spent 20,000 on a holiday, then he spent half of the money left on a house. How much did Gary's house cost? Well, 1 million, that's a 1 with 6 noughts after it. So if we take away the money he spent on a holiday, we can do that as a column sum to make sure we don't make any mistakes. We can't do naught take 2 here, so we're going to have to borrow from all the way over here and then borrow again. So we get £980,000. Then he spent half of the money left on a house. So we need to figure out half of 980,000. Finding half of something is the same as dividing by 2. So I could do 2's into 980,000. 2's into 9 go 4 with 1 left over. 2's into 18 go 9. 2's into everything else go 0. So we get £490,000. And that's going to be the cost of Gary's house. Question 23 on the 4-6 test. Question 14 on the 5-7 test. Look at these two scatter graphs. They are both drawn using the same scale. So we've got graph A and graph B. Which scatter graph shows positive correlation? Positive correlation means as one thing is increasing, the other is increasing as well. So you would expect to see a graph where if you drew a line of best fit like this, it slopes upwards. So I'm going to tick graph B shows positive correlation, and I'm going to put because the graph slopes upwards. Part B says which scatter graph shows stronger correlation. To answer this, I'm going to draw a line of best fit onto graph A as well. That will look something like that. Well, if we look at graph A, you can see all the points here are really close to the line of best fit, whereas here they're not as close. So graph A shows stronger correlation because the points are closer to the line of best fit. Question 24 on the 4-6 test, question 15 on the 5-7 test. Look at the sequence of shapes on a square grid. Shape number 1, 2, 3 and 4. The table shows information about these shapes. So we've got the shape number, the base, the height and the area. Rules connect N, B, H and A. Write one missing letter in each space to complete the rule. H equals something plus 1. So here's H, and that should be one of the other categories plus 1. So we're looking for one less than this really if we work backwards. If we took, for example, the shape number here and added 1 each time, we get the H. So H is N plus 1. It says A is something times 2. So it's saying which one do I have to times by 2 to get this number. And if you look at the H column, if you multiply each one of those by 2, you get A. So we'll say A is H times by 2. And last one, something is 2 lots of N plus 2. Well, let's have a look at the N column. If we times that by 2, that will give us 2, and then add 2, that would give us 4. But at the moment, that could be either this one or this one, so we've got to check another one. If we take this one, times it by 2, that's 4, and then add 2, we get 6, which means it's got to be this one here, because it doesn't work for the base. So we can say the area is 2 lots of N plus 2. Question 25 on the 4-6 test, question 16 on the 5-7 test. Look at this information. We've got 27 over 40 equals 0.675 and 29 over 40 equals 0.725. Use this information to write the missing decimals below. So we want 31 over 40. Well, if you notice between this one and this one, you're adding 2 to the top number each time. And if we look at the difference between this and this, which we could work out using a column sum, 5 take 5 is 0, We need to borrow 1 from the 7. 12 take 7 is 5. 6 take 6 is 0. We get 0.05. So if we want to get from 29 over 40 to 31 over 40, we could say, right, we've got 0.725. If we add 0.05, what do we get? 5 plus 0 is 5, 5 plus 2 is 7, 7 plus 0 is 7, so we get 0.775. Here we've got 23 over 40, so we can do that by starting with 27 over 40 and taking away 0.05 twice, and that's the same as taking away 0.1. So we can do 0.675 take away 0.1. 5 take 0 is 5, 7 take 0 is 7, 6 take 1 is 5, so we get 0.575. Question 26 on the 4-6 test, question 17 on the 5-7 test. In this question, n stands for any whole number. In part A, for the expression 2n, tick the correct statement below. Explain your answer. 2n must be odd, 2n must be even, 2n could be odd or even. Well, if we think about what 2n means, 2n means start with n and times it by 2. And if you take any number and you times it by 2, you get an even number. For example, if we got 16, that's going to give 32. If we had 15, that would give 30. You could try that for any number, odd or even, and it would give you an even number. So that means that 2n must be even. In part B, for the expression 3n, tick the correct statement. Explain your answer. So same choices again, but with 3n. So we've got must be odd, must be even, or could be odd or even. Well, remember 3n is the same as timesing by 3. And let's see what happens when we times some numbers by 3. Let's take, for example, 5 and times that by 3. That would give us 15. Or if we took 6 and times that by 3, that would give us 18. So as we can see here, I've chose two different things here and got an odd number and an even number. So 3n could be odd or even. Let's give a bit more detail. Let's give a proper explanation for these two questions here, though. So we can say for 2n that all multiples of 2 are even. And here we could say that multiples of 3 can be odd or even. Question 27 on the 4-6 test, question 18 on the 5-7 test. On this necklace, the ratio of black beads to white beads is 1:3. How many more black beads do you need to add to make the ratio of black to white 3:1? Let's draw a little bit of a table here. So we'll have black beads, we'll have white beads, and we'll have total beads here. So if we add 1 black bead and 3 white beads, the total beads would be 4. So this is in the ratio 1:3. Well, if we need to have 3 times as many black beads as white beads, and we've already got 3 white beads, then if we don't add any white beads, we're going to need to have 9 black beads to make the ratio 3:1. So that's 12 beads in total. So we need to add another 8 beads here to get a ratio of 3:1. Question 28 on the 4-6 test, question 19 on the 5-7 test. Show that the difference between 3 squared and 3 cubed is 18. All we've got to do for this is work them out. 3 squared means times 3 by itself, and that gives us 9. 3 cubed means times 3 by itself 3 times. 3 times 3, that gives us 9. Times that by 3, we get 27. And 27 subtract 9 gives us 18. So 3 cubed minus 3 squared is 18.